Hey guys, in this video of acids and bases, we will talk about the ionization of water, which will then lead us to the strength of bases. Let's take a look at it. Water can react with itself, acting as an acid and a base to form OH- and H3O+. For this to be useful, we want to find the equilibrium constant, Kc, which is the concentration of products over reactants. However, we make the assumption that since water is in such excess, very little water will actually dissociate into its ions, we can simply ignore the term to form a new constant Kw, which we call the self-ionization constant. And this actually has a value that you should remember. Sometimes in the exam is given, but other times is not. So it's just safe to remember this. At 298 degrees Kelvin, Kw equals 1 times 10 to the minus 14 moles squared decimeters to the minus 6. Notice I said at 298 degrees Kelvin. It is temperature dependent, since the temperature changes the equilibrium position of the reaction. So what you must watch out for is that some exam questions may change the temperature. So how can we use this knowledge? Well, in pure water, we can assume that water breaks down into its ions equally. So the concentration of H3O+ will equal OH-. So modifying Kw in terms of H3O+, we get H3O+ squared. This removes the OH- term. And again, it is still equal to 1 times 10 to the minus 14. And what we can do with this, we can square root it to get H3O+ on its own. With this, we can simply plug into the pH equation. And we get a pH of 7, which should be a very familiar number to you, as it's the pH number for neutral. Remember earlier that the equilibrium constant depends on temperature, and the ionization of water is endothermic. So if we apply Le Chatelier's principles, the reaction consumes energy to go forward. So if we were to increase the temperature, the forward reaction is favoured, as it will consume more energy. This means there is more H3O+, so Kw increases. So to summarise, when it is hot, the pH is slightly below 7, be more acidic, and when it's cold, it is slightly above 7 to be more basic. What else can we do with Kw? With our equation, if we were to take the negative log of each term, we can simplify our equation down to pH plus pOH equals 14, which is the relationship between pH and pOH. But what exactly is pOH? Let's go to the strength of bases. If we were to look at a standard reaction, we have our base reacting with water, which acts as an acid, forming our conjugate acid and conjugate base. And with this equation we can get the basicity constant. And again, we ignore water for it being in excess. Just like acids, a strong base fully dissociates in solution, and a weak base only partially dissociates in solution. So the definitions should be familiar. Taking a look at our Kb equation, just like an acid, if our base is strong, it will mean there'll be more products, making a higher value for Kb. And with bases, it is the OH- we are interested in, which we can simplify by taking the minus log of OH- to get pOH. exactly the same as getting the pH from an acid. So let's look at an exam-style question. What is the pH of 0.05 moles per decimeter cubed of NaOH? Well, sodium hydroxide is a very strong base, which means we know it will fully break down into its ions. As a result, we can simply put it into the pOH equation. However, it asked for the pH. Fortunately, we know the relationship of pH and pOH. They add together to make 14. Using the relationship, 14 minus 1.3 equals 12.7 on the pH scale. It's at the top end, confirming it is a base. Let's look at another question. What is the pH of 0.02 moles per decimeter cubed of ammonia? And as you can see, it has given us the Kb value, which is our clue for it to be a weak base. Not only that, we recognize weak bases as having a small Kb value. Here we will need to use the Kb constant, and we must assume that BH plus equals OH minus, since the base breaks down into its ions equally. So if we plug in our numbers, multiply both sides by 0.02, then square root the lot, we get our value for OH minus. We can sub it into the pOH equation, then use the relationship between pH and pOH to get our value. Which is 14 minus 3.22, and that equals 10.78 on the pH scale. And that's that. It's slightly more work than acids, but it's still easy maths and you should be able to do it. That's all folks, good luck in your studies.